Today we're going to work on solving inequalities. So we're going to start with solving one-step inequalities. Our directions are solve, then graph the solution set, and show all steps. So just like an equation, we're going to pretend like this greater than symbol, k plus 3 is greater than negative 2. We're going to pretend like this is an equal sign. Excuse me. And whenever we see an equation, we always use inverse operations. Same thing with inequalities. The inverse of adding is subtracting. And whatever we do to one side of the inequality, we have to do to the other. So in this case, I'm going to 3 minus 3 is 0. And on this side, I'm left with just k is greater than negative 2 minus 3. Our rule for this was copy, change. The 3 C's. So copy, change, and now I'm adding negative 2 and positive 3. If signs are the same, we add and keep. So we add 2 plus 3 is 5, keep the sign negative. We also at this point in time are allowed to use a calculator, so if you need to, you can always pull that out and just punch it in your calculator. K is greater than negative 5. When I graph on a number line, I'm looking for 3 numbers. I want negative 5 in the middle. I want one number bigger and one number smaller. Remember that when we're graphing in the negatives, our number line has to go in the opposite order. So negative 6, negative 5, negative 4 is how this number line should be labeled, not the common mistake people want to try to do negative 4, negative 5, negative 6 from left to right. But remember that after we hit 0 and we move left, the numbers are going to go in ascending order from right to left instead of from left to right like in the positives. And then k is greater than negative 5. That means that it's not equal to 5, so we have an open dot on negative 5. And if it's bigger than negative 5, I'm going to shade towards the bigger number, which in this case is negative 4. To the right. Shade in my arrow, and I've solved and graphed the solution set for k values that would make this inequality true. We can always double check ourselves. For example, if we plug in any of these numbers to the right of negative 5, 0, 0 plus 3 is 3, 3 is greater than negative 2, so it seems like our answer is reasonable. On number 2, w minus 1 and 5/10 is less than negative 8. We're going to use inverse operations. The inverse of subtraction is adding. And if I add to one side of the inequality symbol, I'm going to add to the other side the same thing. A negative and a positive cancel out to be 0, and I get w is less than negative 8 plus 1.5, which is negative 6.5. When I plot on my number line, I'm going to do negative 7, negative 6.5, and negative 6. W is less than negative 6.5 means that it's not equal to 6.5, negative 6.5, so I'm going to have an open dot. And because it's less than, I'm going to shade to the left towards the smaller number, which is negative 7. Fill in my arrow. And any value that is less than negative 6.5 would make this inequality true. We could use negative 7, negative 8, negative 9. Any of those numbers would be less than negative 8, as long as we use a number that is less than negative 6.5. So when we open up and continue solving, we've got a couple more one-step inequalities. The inverse of multiplying by 4 is dividing by 4. And if I divide one side of the inequality by 4, I'm going to do it to the other. 4 divided by 4 is 1, and 1 times y is just y. Is greater than or equal to 15 divided by 4 is 3 75/100ths. As a decimal, or 3 3/4, either one. So when I plot this on my number line, I'm going to write 3 5/10, 3 75/100ths, and 4. I'm going to go up by 25/100ths each time. Y is greater than or equal to means that it could be equal to 3.75 or bigger, so I'm going to shade towards the right, towards the bigger number. Fill in my arrow, and now I've graphed my solution set for y is greater than or equal to 3 75/100ths. And then in this example over here, t divided by 5 is greater than or equal to negative 2. The inverse of dividing by 5 is multiplying by 5. And if I do it to one side, then I have to do it to the other. So 5 and 5 cross reduce, and I'm left with just t is greater than or equal to a negative times a positive is negative 10. When I graph on my number line, remember that these are going to go in the opposite order because we're in the negative. So we've got from left to right negative 11, negative 10, negative 9. As we approach 0, we get closer and closer to 0. And if t is greater than or equal to negative 10, that means that we fill in the negative 10 box, or fill in the dot at negative 10 because it could be equal to negative 10, or it has to be greater. And so when we think about greater, we're going to shade to the right towards the bigger number, negative 9. We also remember that if our variable's on the left, this arrow points the same way that we shade right here. And then these last two examples are going to throw some fractions at us and remind us of how to solve inequalities with fractions. The inverse of adding 5 1/3 is subtracting 5 1/3. And if I do it to one side of the inequality symbol, I have to do it to the other. Now when I add and subtract fractions, I must create a common denominator. In this case, I'm going to make my common denominator 6. And I have 2 3/6 minus 5 2/6. But then I have to copy, change, because I can't do 2 minus 5. When I do that, signs are different, so I have to subtract and keep the sign of the higher number. In this case, negative 5 2/6 minus 2 3/6, I'm going to have to do some borrowing. So there's a lot to this problem, a lot of work to be shown. I'm going to take 1 away from 5 and make it 4, and then I'm going to add 6/6 to my total here, so that I get negative 4 8/6 plus 2 3/6. All of that is greater than or equal to c. Now when I subtract 4 minus 2, I get 2. 8 minus 3 is 5. My denominator 6 stays the same. I keep my negative because my negative is higher here. And I have negative 2 5/6 is greater than or equal to c. However, if I want to graph this, typically we put the variable at the front. So I'm going to flip-flop those two values. And when I flip-flop those two values, I also have to flip my sign. So it goes from here to here. And c is less than or equal to negative 2 5/6. And so on my number line, I'm going to do negative 3 5/6, negative 2 5/6, negative 1 5/6. Because it can be equal to negative 2 5/6, I'm going to close my circle on negative 2 5/6. Or it could be less than. I'm going to shade to the left and fill in my arrow. That one definitely took some time and thought, but definitely is something that we can do and can show our work all the way through. This very last one says 2/3 times m is less than or equal to negative 8. Now when we have a fraction in front of a variable, we can either multiply by the reciprocal or we can divide by that fraction. If we divide by 2/3, our rule really is keep, change, flip, and then we end up multiplying by the reciprocal. So if you want to jump right to that step where we're multiplying both sides by the reciprocal, times 3/2 and times 3/2, what happens is when you multiply by 3/2, the 3's cross-reduce, the 2's cross-reduce, and I'm just left with m. And then that's less than or equal to negative 8/1. The 8 and 2 cross-reduce to be 1 and 4. And a negative times a positive is a negative. 3 times 4 is negative 12. So right now I have 12 is greater than or equal to m. However, when we graph these, it is a lot easier for us to read left to right and put the variable at the left side. And when we flip m and 12, we also have to flip our inequality symbol so that it reads m is less than or equal to negative 12. And so on my number line, I've got negative 13, negative 12, negative 11. If m is equal to negative 12, I close my circle. It also could be less than negative 12, so I shade to the left towards the smaller number, negative 13, and I fill in my arrow.